So let's see how these power series works. We're going to look at this power series and we're just going to test out one of these series. Okay, we're not going to do too much investigation other than let's just test it out. We're just going to estimate the value of sine of 3. Okay, so this series, apparently if we add and subtract these pieces, we should get the value of sine 3. Now, note that this goes on infinitely, and we only get a certain degree of accuracy depending on where we stop. So if we want to get the exact value, we'd have to do this infinitely, which is impossible. Okay, so this is our series. Now, again, I want to just reiterate there is a power series part to it. Okay, there's a power series. This involves the variable x. Okay, so x can change, and x is a variable in the function. And then we also have the sequence part of this, which is this part here. Okay, so there's two parts to this sequence. Okay, now this factorial happens to make it converge very quickly. It's also alternating. We don't get small. We know that this is going to be a converging series for some values of x. Okay, we don't really know what values of x yet, but we're not gonna even worry about that right now. But we're gonna see, does this calculation, this polynomial actually work? Okay, so I'm going to use the first 1, 2, 3, 4 terms of this polynomial. There are infinitely more, but I'm going to estimate the value of sine using this sine of 3 using this polynomial. So plugging into my calculator, okay, I'm going to end up doing this. Okay, so I'll show you the calculation. So we're going to go sine of 3 is equal to 3 minus 3 cubed over 3 factorial. Okay, well, 3 factorial happens to be 6, plus 3 to the power 5 over 5 factorial. That is 120 minus 3 to the power 7 over 7 factorial. And 7 factorial works out to be 5040. Okay, and again, if I wanted to, I could add more terms to this. Okay, so as I calculate this, I'm going to punch this into my calculator. Okay, so I'm going to go 3 minus 3 to the power 3 divided by 6 plus 3 to the power 5 divided by 120 minus 3 to the power 7 divided by 5040. Okay, and so my decimal value that I'm getting here, the decimal value I'm getting is going to be equal to 0.09107. This decimal goes quite far, but I'll give you the 10 decimals of this. 286. Okay, so this is my add and subtract calculation to get the exact value, of sine of 3. Again, sine of 3 is not a nice angle. It's not, it's not quite, pi, so it's going to be a little bit short of pi. So this number doesn't seem all that unreasonable. So how does this actually compare? How does this add subtract calculation actually compare to the value of sine 3? When I punch it into my calculator, it's not that far off. So the actual value, okay, so I'm going to write down the actual value, okay, is equal to 0.14 1411 dot 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 dot. So it's only 0.05 off of the actual value. So, it's not that close, but it's actually not that far off considering, what it could have been. It could have been very far off, but using only the first 4 terms of this, and mind you, I have an infinite number of terms to get me even closer. That's not a bad approximation. So this is what I'm going to do with these polynomials. It allows me to calculate values of these difficult functions to any degree of accuracy I want, depending on how many terms I use. So these are really nice functions to have, these polynomial functions, if I can get a hold of them. Okay, and things like calculating pi. Well, how do you calculate a numerical value for pi? Right? It's very, very hard. What is the actual calculation? Well, we can now start using these infinite series to be able to help us calculate values of pi. Okay, and this is what computers are doing to get more and more decimals of pi, because it allows us to use these series, which has infinite terms, so we can go on and get any degree of accuracy we want infinitely. So I'll show you also a video of what this actually physically looks like when I'm actually putting this polynomial together. Okay, so we're going to actually be able to see what happens when I just use one term, 2 terms, 3 terms, 4 terms. If I use a 5th term, how much closer it gets. Okay, and you'll see that this polynomial series actually starts behaving more and more and more like a sin x function.